Hello, welcome to Apna Tutors. I am your maths faculty for the class 12 NCERT mathematics. You are having one more faculty for the class 12 mathematics. Her name is Anisa. We both are going to cover the class 12 NCERT mathematics. So moving forward, in last video we had covered the introduction part for the chapter 1 relation and function, where we had covered the each and every concepts of relations and functions. In today's video we are going to do exercise part of the chapter 1, that is we are going to start 1.1, and in that particularly we are going to do first question of exercise 1.1. okay, so let's move. What given in first question is determine whether each of the following relations are reflexive, symmetric and transitive. So here we would be given some relation and we need to identify their property, which type of relation is that, that is whether it is reflexive, symmetric and transitive. Okay, so this type of question are also asked in exams a lot, like in boards they used to ask whether relation is equivalence or not, whether relation is reflexive, symmetric or transitive or not. What we do in equivalence, for equivalence we say relation is equivalence when it is reflexive, symmetric and transitive. So we need to identify property of reflexive, symmetric and transitive. Okay, so let's come back to here. So what given in first question, we are given one set A, which is a universal set which is having elements from the 1 2 3 up to 14, and relation is defined on set A as having pair x comma y such that 3x minus y is 0. So if I write this as R as having pair xy from A cross A such that 3x is equals to y, right? This xy should be from A cross A because R is relation and we know relation is subset of A cross A. So let's see which type of elements will be there in this relation. So if I start with picking x as 1, my y should be 3 times of 1, that is 3. 1 comma 3 will be in R. Then if I pick x equals to 2, then 2 comma 6 will be in R. Similarly 3 comma 9 will be in R. 4 comma 12 will be in R. Now you say me, if I pick x equals to 5, what should be my y? Y should be 3 times of 5, that is 15, and this y is not in A, right? So my xy will not be in R. Why? Because we know R is subset of A cross A, and as my y is not in A, my xy can't be in R. So these are the elements of my relation R. Now let's see whether R is symmetric, reflexive, symmetric and transitive or not. First let's see reflexive. So for reflexive, what we should have, that for every x from A, you should have x comma x should be in R. If this hold for every x in A, the relation R is called reflexive relation. And if relation is not reflexive, then we should find one element x from A such that x comma x is not in R, then it will not be reflexive, right? Because for reflexive it should hold for every element. So for it to be not reflexive, we should find one element for which property does not hold. So let's me first erase this definition. Okay, so coming back here, I can see that if I pick x equals to 1, then 1 comma 1 is not in R, right? 1 comma 1 is not in R. This will give me that R is not reflexive, right? Now let's see next, symmetric. For symmetric, what should we have? That whatever x comma y you pick from R, that is for every x comma y you pick from R, you should have y comma x in R. If this holds for every xy is in R, the relation is called symmetric. So let's see whether that here it holds or not. So if you pick 1 comma 3, 1 comma 3 is in R, but you can clearly see 3 comma 1 is not in R, right? This says that thus we are having our R is not symmetric. Right? Now let's do transitive. For transitive, what should we have? What should we have for transitive? That for whatever xy, for every xy, yz in R, you should have xz in R. If you are able to find element like this, that for every you are able to find element like this, xy is in R and yz is in R, and you are able to find that corresponding xz is in R, then relation is called transitive, and this should hold for every element of this type. Okay, xy comma yz. Okay, so let's see whether it holds here or not. Okay, so here I can see 1 comma 3 is in R and 3 comma 9 is in R, but you are not able to see 1 comma 9 is in R, right? So what I am trying to say, 1 comma 3 and 3 comma 9 is in R, but 1 comma 9 is not in R. This implies R is not transitive. Thus our R is neither reflexive, symmetric nor transitive. Okay, so we are done with first part of this question. Okay, let's move to next part. Okay, so next question, R was given to be having pair xy such that y equals to x plus 5 and x is less than 4. So for this I will give you what will be R. You verify the other properties. How R will be looked here. It will be having, if I take x as 1, let me do here only. If I take x as 1, because x is starts from natural number, what will be my y? X plus 5, that is 6. If I pick x equals to 2, my y will be 2 plus 5, 7, then 3 plus 5, 8, and that much only, because x is less than 4. So this will be my R. You verify the other properties of this relation. Okay, what is next? We are given we are given one set A having element 1, 2, 3, 4, 5, 6, and relation is given that y is divisible by x. So how our R will be look? If I take x equals to 1, then every element is divisible by 1, right? So it will be having 1 comma 1, 1 comma 2, 1 comma 3, 1 comma 4, 1 comma 5, and 1 comma 6. Now if I pick x equals to 2, 2 is divisible by 2, then 2 is divisible by 4, then 4 is divisible by 2, then 6 is divisible by 2, this much only. Then for 3 I will be having 3 comma 3, then 3 comma 6, 6 will be divisible by 3, right? Then for 4, only 4 comma 4 will be in R, and for 5, only 5 comma 5 will be in R, and then for x equals to 6, only 6 comma 6 is in R. So first let's check reflexive. So you can clearly see 1 comma 1 is in R, 2 comma 2 is in R, 3 comma 3 is in R, 4 comma 4 is in R, 5 comma 5 is in R, and 6 comma 6 in R. Hence the given relation R is reflexive. Now let's check symmetric. Symmetric, you can see 1 comma 3 is in R, but 3 comma 1 is in not in R. 1 comma 3 belongs to R, but 3 comma 1 does not belongs to R. Hence R is not symmetric. Now let's see transitivity. Okay. Let me write R again. 1 comma 1, 2. Okay, so this is our R. So now what we need to see whether it is transitive or not. When we say that R is transitive, if we are having for every xy, yz in R, we should have xz in R. Then we say that our R is transitive. That is, for every such type of element x comma y and y comma z in R, we should have x comma z in R. So let's see whether we are having such property here or not. First of all, note that if my one of element is of type this x comma x, that is, if I am having x comma x as one of element, and if I am having another element, say x comma z, if this two element is in R, then of course I will be having xz in R, right? Because of course xz is in R from here only. So whenever if I have one of element of x comma x type, then transitive means this property will hold, that is x comma y, y comma z is in R, then x comma z is in R. This property will hold if one of element is of type x comma x. So we do not need to verify such property for this type of element. So I will not need to say for this element. So if I pick 1 comma 2 and corresponding to 2, I am having many options, 2 comma 2, 2 comma 4, 2 comma 6. But for one, suppose I pick 2 comma 2, then my 1 comma 2, 2 comma 2 is in R. This implies if this for transitivity to hold, 1 comma 2 is in R. 1 comma 2 should be in R, right? And we are having 1 comma 2 is in R. And we are having 1 comma 2 is in R. Thus, here it holds. Here it holds. Now let's see for 2 comma 4. So 1 comma 4, 1 comma 2 is in R, 2 comma 4 is in R, and we are also having 1 comma 4 is in R. So similarly, for 1, picking x as 1 will always have corresponding element. Why? Because for 1 we are having every xy is in R, sorry, every 1 comma y is in R, where y belongs to A, that is 1 comma 2 comma 3 comma 4 comma 5 comma 6. Okay, so we need to see for other element. If I pick x equals to 2, and if I pick this element, I don't need to see, right? So now let's move to next 2 comma 4. So for other element corresponding to 4 is 4 comma 4, again by this property. Let's name this as 1. Again by 1, we don't need to see for 2 comma 4 comma 4 comma 4. Then if I move to 2 comma 6, and corresponding to 2 comma 6, other element having first component as 6 is 6 comma 6. So again by 1 it holds. Now let's move to 3 by again 3 comma 3. So again by first property it holds. If I pick 3 comma 6, then another element having first component is 6 comma 6. So again by first property it holds. Similarly, for 4 comma 4 by first property it will hold, and for 5 comma 5 and 6 comma 6 first property will give that. So overall I can see R is transitive, because for whatever xy, yz we are picking from R, we are having xz in R. So we can say our R is transitive. Okay, let me clear this. So we are done with third question. Okay, so fourth question is in homework. It's easy to do. Now I had did first also and third also, and for second I had given you the lesson. So fourth is in homework. Now let's move to fifth. What fifth is saying? Relation R in set A of human being. Our universal set A is defined as set of human beings. HB stands for human being. And we are given R as, if I do one of the question from this, suppose I do first one, R is given as element xy such that x and y works at same place. Okay, so let's see whether R is reflexive, symmetric and transitive or not. As you can see, if I pick any x from A, that means if I pick any human being, then of course x comma x will be in R. Why? Because x and x will of course work at same place, because they are same element, because they are same person. X and x work at same place because they are same person. They will of course work at same place. Hence x comma x in R for every x we pick from A, that is for every human being. Hence R is reflexive. Now let's see symmetric. That is, let's say, let xy, let me do another page only. Let xy belongs to R. What does this mean? X and y works at same place. But this also means that y and x works at same place. This will imply y comma x belongs to R, because this is what property R is defined as, right? That two elements y comma x will be in R if y and x work at same place. So for every x we are having that whatever arbitrary x we pick from R, we are having y comma x is in R. Hence R is symmetric. Okay, now let's see whether it is transitive or not. Okay, so for transitive, what we need to say, we need to pick element like xy, yz is in R, right? That is x and y works at same place. Also we are having yz is in R, right? So y and z works at the same place. But this also means that x and z works at same place, right? Because x and y works at same place and y and z works at same place. So x and z works at same place. This means x comma z is in R. Thus this implies that our R is transitive, because we had picked arbitrary element from R, right? Because we had arbitrarily picked x, y and yz from R, and we are having xz is in R. So our R is transitive, hence our R is symmetric, reflexive and transitive. Okay, so I did A part, sorry, I had completed A part, you do other part, they are similar as A part. Okay, so that's it for the today's video. In the next video we will be doing more questions from the exercise 1.1. Yeah, so thank you. Please like and subscribe to our channel. We'll meet in next lecture.